3 ways to prove triangle similar. What do you got for me? You can look back if you want. Angle, angle. That's the main way we use in a proof, remember. Angle, angle. Another way. Side, side, side. Similarity, which means what about the sides? They are in the same ratio, yes. And then we also have side, angle, side. What do we know about the angles? They're congruent, and the sides are same ratio, okay? And then anybody remember, because this is where we're going to continue today, after I prove the triangle's congruent, what do I know about the, after I prove the triangle's similar, what do I know about the sides? So the 2 triangles are similar. What do you know about 2 corresponding sides? Same ratio. Anybody know how we abbreviated that in the reasons column of a proof? CSS TP. All right, that is where we ended these proofs before we started reviewing for the midterm. We proved 2 triangles similar, that we said the sides are in proportion because of CSS TP. We're going to take that one step further today. All right, one step further. All right, first thing. You guys may not realize this, but when you set up a proportion, there's actually different parts to it. Everyone see where A and D are. Okay, whatever numbers you end up putting in for A and D, everybody, we refer to those now as the extremes. Okay, we refer to those as the extremes of your proportion. And the other 2, B and C, we're going to start referring to them as the means. How you remember that, I'm not too sure. I've heard kids say, especially the extremes, you're going downhill, extreme downhill, racing, skiing, whatever you want, however you want to remember where the extremes and the means are. All right, the extremes are going downhill, left to right. The means are going uphill, left to right, however you want to remember that. How do you solve these? How do you solve a proportion? Cross multiply, and you do what with each side? You set them equal. That's the big theorem for today. When you multiply, anybody remember what the answer was called? When you multiply 2 numbers to anything. Product, you ready? Product of the means. So when I multiply the means, the product is equal to what? What do you said it equal to? Product of the extremes. All right, this is going to go the last reason now in our proofs. And I don't know if anybody's starting to think it or will think it. POM equals PO will not be a shortcut in here. We all good on that? POM equals PO, not a shortcut. All right, let's write it out, please. All right, let's dive right into it. Get the number generator back running up again. You guys can go ahead and mark your diagram with whatever you have to mark it with. AR congruent to RT. I got right angles. All righty. Look at the proof statement. Everyone see we're going to multiply segments. So that signals, okay, multiplying product of the means and extremes. But hey, guys, we cannot even write that down until I know what about the triangles. Similar. I have to prove triangles similar first before I can say the means and extremes are equal. Oh, well, that leads me into another problem. Look how many triangles are in this diagram. Are you just going to pick 2 and say, let's do it? No. How can I figure out, is there anything up here that will help me figure out which 2 specifically I need to prove similar? Mason. Look at the proof statement. Everyone ready? What segments? Give me a segment involved in the proof statement. ER. All right, everyone, take a look. ER. That is a full side, and how many triangles in that diagram? Only one. So it looks like it's going to be triangle ERT. Somebody name another segment from the proof statement. I didn't. Well, let me go AD to prove a point. AD, is that going to be good enough to find the second triangle? No, look, it could be this one on the right, could be this one on the left. I don't know. So let's keep going. What's another side here? TE, I've already used. And what's the final segment? DT. So does everyone clearly see it's got to be triangle ADT? Okay, let's prove them similar. What's the main method we're going to use? Angle, angle. Somebody get me a pair of angles. Here we go. Start calling on people. Get me a pair of angles in those two triangles that might be congruent. 25. Because they're what? And here's great news. You don't have to write it down. I already gave it to you. So we can go to say, yep, angle TER congruent to ADT. Right angles are congruent. One pair. Where's the other pair coming from? Use your givens. Use your givens. We talked about the right angles. We didn't talk about the congruent sides, though. Where's the other pair? I got a 5 here. Nope. Yes, we do. Here we go. Fiona, where's the other pair going to come from? These two sides are congruent. Okay, I like angle R. I don't like you saying angle T, though. ATR. Everyone see those two? All right, I'm going to ask somebody in a second why. So angle R is congruent to angle ATD. How do we know those two are equal? Let's go. Let's go. 18, 18. Only in a what, though? I got to have that in a triangle, because that doesn't work in a pentagon, in a quadrilateral. In a triangle, congruent angles across from congruent sides. You got the two pairs of angles for me. Check. Now what do I know about the triangles? Similar. Write a correct statement for me now with the similar sign, not the congruent sign. 21. We got a 21 in the house. Triangle. RET. Similar to. TDA. I'll take that. By angle, angle. All right, here's where I always get a ton of confusion. You got the triangle similar, congratulations. The means and extremes are not equal yet. What do I need to build first before I start cross multiplying? I need a proportion to cross multiply in. I don't have that. So what you guys need to build before I say the means and extremes are equal is a correct proportion. You cannot just go from triangle similar, means and extremes equal. You got nothing to cross multiply. You got to build it first. Here's the easiest way to build it. What's one segment in the proof statement? ER. All right, so I'll place ER right here. It doesn't have to go there. It can go in any one of the 4 spots. But wherever you place ER, where does AD have to go if I'm going to multiply it in a proportion with ER? Not down here, because I'm not going to cross multiply that one. I'm going to cross multiply. So it's got to go right here, everyone. Take a look. ER and AD. They have to be diagonal from each other. And then you can put TE and DT wherever you'd like, because I am going to cross multiply those wherever I put them. And then before the midterm review, why are the sides in proportion? That's CSSTP. Now that you've built yourself a proportion, cross multiply. And yes, the last step, we can say ER times AD is equal to TE times DT. And that's our theorem product of the means equals product of the extremes. Questions there? So does everybody see? You can't just go from proving the triangle similar to means and extremes being equal. You need to build the proportion. All right, I will give you and your group a couple minutes right now. Mark whatever you have to mark on your diagram, but also now find the two triangles you need to prove similar in this diagram, because there are a ton of triangles there. So read through the givens, see if you can mark anything on your diagram. Doesn't look like much here, it's just a parallelogram. And then find me the two triangles I need to prove similar first before I can say the means and extremes are equal. All right, can I have from somebody which two triangles to prove similar? 14, which two triangles are you picking? Which ones? Q's the big dog, yep. This one right here. Similar with, which other one, Caleb? QP, yep. This one right here, right up on top of it. All right, got to get those similar. Those are the two, according to those segments. All right, and really, we are just going on the pure fact it's a parallelogram because there's nothing else in there in the givens. So properties, properties, properties of a parallelogram. Pair of angles anywhere? 14 again, Caleb, any angles knowing it's a parallelogram? That's this angle and this angle, no. Opposite angles are equal, so that angle is equal to this whole one, but that's not in either triangle, so. Say that again. These two? Got it. Yep, got them. So angle QRC congruent to angle QP. What is that, QPA? Is that an A there, QPA? Why is that true? Why are those two angles? Let's go, 29, yes, no? Parallelogram implies opposite angles congruent. There's one pair. Nice job, everyone. There's one pair. Where's the other pair come from? It's a parallelogram. Parallelogram. 27, yes, no? What do I know about opposite sides of a parallelogram? They're parallel, all right. So if they're parallel, these two sides are parallel. Do we see any special type of angles formed by those parallel lines? Or let me do you can do these two as well. I don't care. Any special type of angles formed by either sets of parallel lines?
Alternate interior angles, but I just don't see how they're. Oh wait. Oh, angle C and then angle NQP.
These two? Yep. And if you went with everyone take a look. If you wanted these lines here, parallel, you could have said these two are alternate interior right here. Okay, these two. It's up to you. Just make sure you have the correct set of parallel lines. All right, so R, anybody a little help with this letter here? R, S. Okay, RS is parallel to QP. Parallelogram implies opposite sides parallel. Okay, because we're doing this, though, I can't just say the alternate interior. Anybody see why I can't say the alternate interior? This angle's not formed by RS, it's RQ or RC. So how do I make it longer? Extensions, yes. Hey, here I do, but if you did it here, you don't need to go parts of parallel lines. You can just say they're congruent. But because I'm choosing these, RS does not form angle C down here. So I do need to extend it out now and say RC parallel to QP. Extensions of parallel lines are parallel. Then I can say those alternate interior angles are congruent. So angle C congruent to, what's the other one up there? PQA. How do I start this reason out? By saying the alternate interior angles are congruent. So I can't write that. I have parallel lines imply alternate interior angles congruent. What do I know about the triangles? They are similar. Write me a statement. I got a 1 in the house. Maddie, give me a good statement. Triangle.
Triangle CRQ
Similar.
is similar to triangle Q
PQA. I'll take your word. Angle. What's got to be created now? Again, you can't, I'm going to try to drive that. You can't go right to means and extremes. You have to build the proportion to cross multiply with. So I'll let you guys build that now. Look at your proof statement. Look at the two segments you got to multiply and place them in the correct spots. Give me a good proportion. 15, give me a good proportion.
QC over AQ.
Okay, oh, QC over AQ. Got it, Henry, keep going. Equals, yep.
CR over
What was the last one? Q. How do you do? QC, QP, nice job. Not means and extremes, why? Why are the sides in the ratios? CSSTP, not means and extremes. Now you can cross multiply. Product of the means equals product of the extreme. All right. I'd appreciate it if you do not pack up until the bell rings. I don't care if you start on the additional quadratic ones on the back of your assignment sheet or you start on the packet proofs. It's up to you. Either way, you're doing quadratic formula tonight or factoring.